Okay, the video stopped. So, okay, I gotta get that's a video of it. Whoa, we're like going into like alternate universes here when I take a video of a video. Do you know the answer to that third one? Nice. 3 over 6. Don't pi, don't pi. All right, 3/6 is 1/2. So we lost the video, so that have to be two. I don't even know if I can splice those two in this program. All right, next. Oh, I think it hit stop sharing. That's why. All right, and then last but not least, nice. All right, so we have sine and it's a negative. So we're at 5 and -5. Oh, two absences, right? Didn't you miss Monday too? We all missed Monday. What's today? What year are we in? Is this 2022? You know, we're almost on the 2-year anniversary of all this fun we've had. All right. Okay. So what's the first one? Is it 0, 5, or -5 for sine? Try to emulate what everyone else has done. You've had a cosine example, but upside down. Cosine Kid, you ever see the Karate Kid, by the way? Have you? The crane, remember the crane? This is like the cosine Kid, the crane, but upside down. Crane move. You remember that? Okay, I can't hear you, so you shake your head. All right. And then sine starts at a different spot. So 0, then high point, 0, low point. Okay, so you have a sine, but it's upside down. So what's the first point? 0, comma. Is it 5, 0, or -5? Nice. It's an upside down sine curve. So what's 1/6, comma? Oh, it's upside down. So it's there. Now we're getting somewhere. You're learning from the things that you didn't look at yet. And then what's 1/3, comma? This is why we need to do our stuff when we're missing. 1/2, comma. And then 2/3, comma. All right. We had an extrapolation on Tuesday that you missed about why these points occur. The extrapolation is over. Now it's memorization. Okay, this is what the points are. Did I do that right? What's wrong? Huh? I'm kind of curved. You don't think that's curvy enough? I didn't just stop. I did put an arrow here. No, it's kind of like still going down, and then so I don't really like do a little loop there. On cosine, though, I do a loop because this is definitely looping around and going back up. This is the absolute low point, so that one I do have to loop. The other ones kind of just keep going in that direction because they are going to keep, kind of not. I won't say straight, but all right. So good. Was that the first bell?
Yeah.
Oh no. All righty then. Okay, now it's the time for the notes. Oh shoot! Don't look! Don't look! Don't look! I forgot to get rid of that. Okay, so go ahead and write those directions down. I did this perfectly when I used the worksheet generator to just make up some examples for notes because I know what I'm doing. I don't need any. I don't think we need a lot of extraneous words, extra, verbiage here to confuse you. Okay, so find the amplitude, the period. We already know how to do that. We're building on it now. Okay, I'll talk about phase shift here in a minute. And I'm not calling. I am stuck on 20, right? Was the last person. Let's get you warmed up, though. Student number 6. 3, 6. Nice. No. Yes, it is him. Thank you. All right. Alexis. All right, so A is certainly amplitude. All right, let me move myself over here. Because I want to take green. That's definitely what the amplitude is. B is not the period. B creates the period, and the period is equal to 2 pi over whatever that number is. So just make sure you remember that and mark it again. All right, and then here's your new math words for the day. So hopefully you wrote this exactly like this, and then you can get a highlighter out. For some reason, they call the word phase shift this number in here. Oh, I got you, Alexa. So you are going to go on this. What does that mean C is for a function? Which way does the function move? Or, you're just giving me thumbs and fingers. Apparently you can't talk right now. So it's right or left. For some reason, they call right-left shifts in trig a phase shift. I could probably look it up. There's probably a really good reason for it. I just don't know what it is. Or I may have looked it up before and I don't remember. I don't know. Not a big deal. And then what is this D then, Alexis? Oh, you're going to talk now. Okay, up and down. All right. And then remember, Alexis and everybody else, that this is what happens with this. If this is -2, then that's 2 to the what, everybody? 3, 2, 1, go. Right. If this is +4 on the outside, what is that? Up or down? 3, 2, 1, go. So outside, it's opposite, same. That's what you got to remember for this. Okay, so I think, no, Alexis, you're going to give us our parts here of this first situation. So what's the amplitude? Is he just holding up a number? Oh, 1. What's the period? I hope the sound is working, by the way. I didn't check again. Oh, so I see what you did there. Nice. That was good math, too, by the way. But this is not in the B position. This number is 2 pi. Well, boy, you did good math on that, quickly getting, if you did do 2 pi over 4. No, actually, that would have been wrong. 2 pi over 4 is what, everybody? 8. All right, so I know what you did there, but it did not quite go. But that's not what happens. So what is that pi over 4? What is that called? Our new word for the day is what? Phase shift. In which direction is that phase shift? It is right. I'll just put it like this, colon, and then say pi over 4 right. And then is there an up-down shift? No, I don't have one. It's not really that hard. As a matter of fact, I think I'm only going to do 2 graph examples and then just show the 2 others what you should know about it, and then we'll be done. And I even said I'm only going to do 1 period of this, but I'm going to do 2 on the video. But here's what you do. Watch. You don't want to go right to the x-axis and start marking it because you have a graph, but then it's shifted. So what I want to know is what are my key values? Where do I want to start my picture? So I really think the smartest thing you do is do your math off to the side. So what's the period again? 0 to 2 pi. And I think he has done enough, so let's get a new student. Enter. Nice. All right, I do have to move my head again. Boy, why don't you just get rid of yourself? No. All right, what's half of 2 pi? What's half of pi? 1 pi over 2, 2 pi over 2. And then to move everything pi over 4 to the right, what should I do? Add or subtract? Add. You're going to add pi over 4 to all of these to know where this graph starts. And then for our first time doing this, I'm going to write it in all of these. But then you also could do some pattern recognition. It seems like I'm writing slow. It's because my pen and computer are stupid, and they constantly don't let me write, and I have to write pi like 5 times before it actually writes. And you know that. And it drives me nuts. And every little day I get closer and closer to insanity with the computer I have to deal with. Alexis, what is 0 plus pi over 4? Oh my goodness. What is 0 plus pi over 4? Okay, so the first one's easy. The next one, Alexis, get ready for the wrath of Samuelus. Because if anyone walks out of here and says, boy, this is really hard, you're admitting that you nearly failed 4th grade math. Because to add fractions, all you need is a common what? 3, 2, 1, go. Denominator. What is the common denominator between 2 and 4? 4. So all I have to do is multiply this by 2 and 2. This blows my mind, you seniors. And then what are these 2 added together again? Or not again. What are those 2 added together? Plus pi over 4. 3 pi over 4. All right? And then you might start seeing a pattern after our next answer. What's the common denominator here? I'm not even going to ask you. I'm just going to go ahead and shove that in there. What's this next one added together? 5 pi over 4. Do you see a pattern to the right? So what do you think the next one will be? You are correct. Sometimes we are humans and we recognize patterns. What's the next one? So you can see that these keep going up by 2 pi over 4, which is not a coincidence. 2 pi over 4 is pi over 2, which is how far away each one of these green values are. So the red values should be pi over 2 away from each other, which is 2 pi over 4. So one way or the other, this is how you get your critical values. And you know what? We're going to go ahead and graph 2 cycles. 2 periods. Now I want you to work on this. You high flyers, the ones that are actually doing quite well and do their homework and have that caring and do stuff when they're absent and all that other stuff. That is the only way and path to success in this class. Have I mentioned that before? Yeah. Okay. So pi over 4 and 3 pi over 4. These are pi over 2 away. Whereas this pi over 4 is only pi over 4 away from the y-axis. I really want you to focus on this. So I'm going to make this pi over 4. And then my next distance should be twice as far as that distance to the y-axis. Because that distance is pi over 2 away, which is double the distance from the y-axis value there. And you really want to work on this. You want to work on your spacing in reference to the where everything is as far as the origin is concerned. All right, and then the next space should be equidistant. 5 pi over 4. I think I'm going to run out of space. 7 pi over 4, but I really want my distances. So I'm going to leak into the next question. 9 pi over 4. I'm just going to extend this line without getting rid of that arrow. Come on. I'm leaving the arrow. Okay. All right, who do I need next? Hopefully it's someone sleeping. 3. Kathleen, loud and proud. Okay, so we have sine, but this is the start of the sine curve. Here, not here, here. How does sine start? Is it at 1, 0, or -1? Nice. And then what's 3 pi over 4, comma? Nice. What's 5 pi over 4, comma? Next one. Next one. It's easy after you get that done. Now I'm going to do 2 periods. This is why this one's kind of stinky. This is the second worst type of question where something occurs here. Because the next iteration, the next sine curve, I would go over here. And the y-axis does not get to play. It's not a critical value. Because how far away are these away from each other? This answer. How far away? 3, 2, 1, go. Pi over 2. So pi over 2 this direction, what is this right here? What is that next critical angle? 3, 2, 1, go. Negative pi over 4. That is pi over 2 away. That is equidistant from here to here as it is from here to here and all the other critical values. The y-axis gets skipped as a critical value, and you must know that eventually. So why not throw it out there now? We're doing good. All right. So then this would be the -1 value, and then guess what? -3 pi over 4, -5 pi over 4, -7 pi over 4. 0, 1, -1, and then that's how it would continue. So actually not that bad. Whoops, I never graphed the original. My bad, dogs. All right. I just got lazy. It's -3 pi over 4 here, -5 pi over 4, negative. Lucky, this is nice how they're this nice little pattern on the critical x values. It's not that the y-axis isn't crossed. It's just it's not a critical value. You can't make this -1 here. It's not. It's over here. Right? And that's what I want you to understand. All right, next one. Whew, man, this is it. Got some people sleeping. Should I punch the cabinet? I used to do that. And then I scared my first hour 2 years ago. Was that COVID class 2 years ago? When the world ended with that? I think that was 3 years ago. Well, I don't even remember. No, it was 2 years ago. The first time we had COVID. You ready, Jennifer? Your sister was in that class. In that first hour. She'll remember about me punching. Ask her about when I punched the cabinet and everyone got scared. And then I had to bring this guy out because I'm like, hey, Nick, you can't be one of these guys when I punch the cabinet. Oh, my gosh, Mr. Samuelis. Oh, you're scaring me. Oh. That's all. It all came back to me. That's true. It's exactly what happened 2 years ago. And I felt so bad. I almost wanted to give that to Nick, and but then I didn't. I still have it. So anyway, ask your sister about that, and then we can continue. So Jennifer, what is the amplitude? What is the period? Yeah, don't get tricked on that. You got that 1 there. It's just 2 pi over 1. This is the worst kind of question, by the way. When the period and the phase shift, what is the phase shift? To the what direction? Correct. And then, oh no, this isn't hard though. The -1, which way does that go, by the way? Down 1. I don't know, I'm just going D1. Okay, then I'll show you how you do this. Well, here's how we got to do it. You know what? I'm done with this, so I'm just going to erase this and get that out of the way because I need my work off to the side. And then, unfortunately, I only had 2 examples with a period of 2 pi. So we're going to do this. And actually, you're done unless the calculator likes you and picks you again. 15. Is that you? I think it is. Oh, wait, 20, 19, 18, 17. That's you. All right, 15. All right, so here we go. We have to subtract pi over 3. I'll do the first one. That's negative pi over 3. Actually, it's not really too bad to do 2 things, but all right, now I got to do this. Nate, what's the common denominator between pi over 2 and pi over 3? When you're adding fractions, what would you have to get? Okay, so multiply by 2. So what's the common denominator? Okay, then what are these two? What's 3 pi over 6 minus 2 pi over 6? Pi over 6. And you need to do what I am doing right here. You need to write this crap down if you can't figure it out mentally and understand how to get common denominators and subtract. It's got to happen. You're going to subtract pi over 3 again from this one. What's the common denominator? These two? So what do I have to multiply top and bottom by? 3. I got to make you say it so it solidifies in your head and we get this stuff taken care of. What do we end up getting? What's 3 pi minus pi? What's 3 minus 1? 2 pi over 3. We're getting your fractions work here. Minus pi over 3. What's the common denominator, just like 2 ago? 6. So I multiply by 2 and multiply by 3. 3 times 3 is? 9 pi minus 2 pi is? 7 pi over 6. I hope I said that in the other. Yeah, okay. And then the last one, this one, the pattern's a little bit weirder, but I could go every other and see what we're getting. So pi over 6, 7 pi over 6, that's 6 pi over 6 away. So I'd add another 6 pi over 6 to jump the next 2. But this one is an over 3 because I'm going to subtract pi over 3, multiply by 3 and 3. What's 6 pi minus pi over 3?
6 pi minus pi over 3.
What's 6 pi minus pi? What's 6 minus 1?
5.
Pen. Okay, so ooh. Now yet again, negative pi over 3 is twice as far as pi over 6 is from the origin. You need to work on your spacing. I'm not going to get a ruler, but I do get annoyed with people that don't associate how these fractionally are compared to the origin and how far they are. I do get annoyed. I don't know if you've noticed that. All right, and then now this distance from here to here, this distance is the same from here to here. So this total distance from here to here, I probably should write that is the same as this distance from here to here. And I'm going to erase those things. 2 pi over 3. And now that I see that distance, that should be about the same. So you really got to work on your neatness here so your graphs aren't too awkward looking. 5 pi over 3. And now I'm going to get someone else, and then we'll talk about. So number 1, nice. Mitchell, This is a cosine. So what's my first? Let me write the amplitude down. What's my first point? Negative pi over 3 comma. What is it? 2 is right. And then yet again, Mitchell, not 0 comma. That skipped. What's pi over 6 comma? 0. So this is the tough part. 2 questions where the y-axis is not a critical value. You can't make it a. None of these say 0. None of these say 0 is a critical value. It must be skipped. 2 pi over 3 comma. 7 pi over 6. And then the last one. You got it. All right. And honestly, I could have probably done another period worth, because really what it is fractions. Remember, Adam? Look at how he did those curls at the end. Those start coming back down. The next values, it's going to be a pi over 6. And these are pi over 2 away from each other. So all I have to do is subtract another pi over 2, getting a common denominator. All right, so what would that value be? Anyone? Do you know it, or are you just asking a question? Are you just doing nothing? Are you just waving it? What is this? Are you raising your hand? Oh. Okay. That was awkward. All right. Actually, I'm having trouble on this one. Is it negative 5 pi over 6? I think it is.
What's the question?
No, is anyone listening to me? All right. If I were going to do another period, I would just have to go pi over 2 that way, because everything's pi over 2 away from each other, right? So all I would have to do is take negative pi over 3 and subtract another pi over 2. I'm actually having problems with my like the patterns on this one. This one's a little tougher. Isn't that negative 5 pi over 6? So the next critical value would be negative 5 pi over 6, and then that would hit 0 again, and so on and so on and so forth. Are you holding your head together because it's about to explode? Nice. That's what absence does. All right. Do you have a question, or you did do what he did?
About like the up and down.
Uh-huh.
I was like, dude.
Son of a nutcracker! I completely forgot about this. Thanks, Ivo. I guess in our last 4 or 3 minutes, I screwed up. Worst teacher ever. All right, so this is what we got to do. You know what you can do? On your paper, you can select your graph and just move it down one. There you go. Done. All right, good. All right, oh, that's just the point. Oh, come on. Can you, what? Would you get out of the way? Okay. Where's the, there you go. So Ivo, you know what you should have done? Is Ivo, I'm so sorry. All right, this is actually 1. This is negative 1. So sorry, Mitchell, you were wrong in every case. It was your fault, because you should have said negative pi over 3 comma 1. It's his fault. All right, and then pi over 6 comma negative 1. And then 2 pi over 3 comma negative 3. See how I can do that? Relieve myself of all responsibilities. Thanks, because that's exactly what you do. As a matter of fact, all kidding aside, here's what you should do when you have an up-down shift. You should make a new dotted line x-axis, and then those are where the zeros are located after that. Okay? All right, as you shuffle to get your papers out of here so you can get out of this class that seems to take forever. All right? Let's all do this as a class together. What's the amplitude? 3, 2, 1, go. What? What's the amplitude? 3, 2, 1, go. What's the up-down shift? Say up or down. 2, 3, 2, 1, go. Up 1. They put it out in front. What's the period? You're going to be okay on this. 3, 2, 1, go. No, it's 2 pi over 2, which is what? The phase shift is not 3 pi over 2, because what you got to do is take this out. First of all, what does this become when you take out? Get that crinkling of that water bottle at the end of the class. What happens when you take out a 2 out of this? This becomes 3 pi over 4. All right, so what's the phase shift? Actually, 3 pi over 4 to the right or left, right or left, right or left. 3, 2, 1, go. Right. What'd you say? What'd you get? What is that? Nice. Is that yours? Does it still smell?
Yeah.
Let me see. I think that's part of a rainbow. No, what? Did you get this? No, it was a butterfly. Do you have it, or did someone lose their butterfly part? Oh, I didn't end the video. Sorry. Oh, I have one more class to go. Oh.